evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Tonight we're going to take a look at the upcoming Earth Day and how you can help your students with some mathematics and some lessons, even as we transition to this unusual and different time in our classes. My name is Mike Houston. I'm a moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight I'm excited to be joined by Tom Reardon. Tom taught for many, many years in the classroom, and now he's currently working for Texas Instruments in product strategy and development. So, Tom, it's great to have you with us tonight.
Hi, Mike. It's good to be here. Good to see all these people here tonight.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to Tom using the Q&A window on the right side of your screen, and we'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but if you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Tom is going to discuss our agenda.
All right, so we had the welcome. So we're going to have a statement of several interesting applied problems dealing with straw usage in the United States. Tonight I'm going to give you time for the participants to at least begin the solutions of the problems. These problems use units conversion, perimeter, area, and volume. You can use any calculator you want, hoping that students utilize different problem-solving techniques. And I'm going to show you how to do this activity in the classroom, but also how to use it as an online remote activity with pre-created videos. And at the end, we're going to have a webinar drawing.
Tom, thanks so much. You should have control. Feel free to share your screen.
Okay, so that's up and running, Mike. We're good?
Yep, we're good.
All right, thank you. So before we start, a little disclaimer here. Mike suggested I do this little disclaimer, and I agreed. So I've done several of these webinars over the years, and I really enjoy doing them. Tonight I'm trying some things new. Not something new, but some things new. So I'm going to go slower than I usually do. Normally I have 5 hours of stuff, and I only have like 50 minutes. So I'm going to go slower. I also created an online remote learning version of this activity that you can use with your students tomorrow or even after tomorrow. So it includes a video that your students can play and interact with, similar to what you're going to do with me this evening. And that is, you can assign this activity as your daily lesson. So if you need a day off tomorrow and you teach something this would apply to, just give this to your students and you've now taken care of tomorrow's lesson plan. But I want you to do the math with me. So there will be pauses and quiet air for you to do the problem. And I know it's going to sound weird when there's nothing going on, but I do want you to do this because I want you to see what the math is and experience it so you know where this applies for your students. And probably for once, me doing a webinar, the technology is not the star of the show. Problem solving, the applied math is, and it's really more for grades 7 through 10, but I'm sure juniors and seniors would get a lot out of this too. So with that, we're going to go ahead and get started. Mike's going to be watching the Q&A, so if you have questions, make sure you get those out because I will have time to answer those at the end, I'm sure of it. So this started because Parade Magazine, some of you get that on Sundays, but 2 years ago, this was the cover of it. And it intrigued me. I'm really a big fan of taking care of environmental issues. And one of the things that shocked me was how many straws are used in the United States each day. So what we're going to do is when I ask you some questions, before you type in the answer into the chat, but I think we all should press enter at the same time or send at the same time. So if you want to go ahead and type in what you think, how many straws Americans use every day, go ahead and type that in, but don't press enter until I give you this word, and the word tonight is going to be Pez. Okay, so that's the word. All right, so you can type in a Q&A all you want. Chat, answer questions, wait till you get to go ahead here. So I want to thank Steve Phelps for this idea. I think it's a great idea. It's just like students not yelling out the answer. You asking a question, the kid yells out the answer, and as soon as the answer goes out, all thinking stops. So we don't want that to happen. All right, so how many straws do Americans use every day? The number should astound you. It turns out that many of them end up in the ocean along with plastic bags where sea life accidentally consumes them, and 90% of the debris in oceans is plastic, unfortunately. So how many straws do they use every day? Go ahead and press PEZ. Go ahead and press enter, rather. I notice some of you put in an answer and already did it way before I said that, so please go along with me on that, okay? All right, so let's go see how close you were. 500 million. 500 million? By the way, that's not factorial. That's just an exclamation point there, okay? But that was shocking to me. Now, not all of them are plastic. I'll grant you that. But for this activity, we're going to say they're plastic. You'll see why in a little bit. But that, to me, was astounding, okay? All right, so to me, that didn't make, I can't comprehend 500 million. I have a hard time comprehending a million, okay? So I wanted to do is let's investigate this in some kind of context. And that's really what these activities do. They're trying to get you to think about what these large numbers mean in context and do some good mathematics and problem solving. So one of the things that I have on the student PDF is that students should use a calculator to do their calculations. It doesn't matter what kind. I prefer an 84 Inspire. You could do a scientific calculator, but with the 84 Inspire, I want students to store their intermediate answers into a different variable and make note of that variable on their paper in the solutions. I want them to keep as many significant digits as they can. And we're not going to round any intermediate answers, but only round final answers to 3 decimal places. That's going to be our rule. That way, everybody should be getting the same numbers. So I know you're not messing up here. So you need a piece of paper and you need a calculator. So if you don't have one of those, go grab one real quick. Be prepared to pause the video. Well, if you're doing this as a video, you pause as a video. You do it as asked and I'll continue. I'll give you some time for that. So here's the plan for students. This is more for the students, but you'll get it here. So I want students to do this problem as if they were in my math class along with me as the teacher, and I'll ask a question and I would expect them to go ahead and do the work. And then once they've all tried that or got stuck or whatever, then we will play the video and I will tell them what they should have done. But I want them to try it first and continue and make corrections as needed. That you can download the student PDF at this website, which we will talk about later, and Mike will have that also in the materials afterwards. Or you can just use a piece of paper. You can follow everything on the video. If you want to use it as a standalone, once we get back into the classroom, you've got a student PDF as well. So let's go ahead and get started. So here is exercise 1. So if we connected these straws for one day, put them tip to tip, and could place them along the equator, how far would they wrap around the Earth at the equator? So what I would want my students to do is they would be in groups, and I want them to talk about what information do I need to provide you in order for you to be able to answer this question, okay? So again, you can go ahead and type those into your chat window, but do not press send or enter until the magic word PEZ comes up, and that didn't count when I said it just now, okay? So type in your questions, don't press until you hear the magic word. So go ahead, I'll give you 30 seconds. Some of you are already pressing enter or send. That's not the plan. Not the plan. You guys aren't listening. You're not listening. Fortunately, I don't know who you are, but I just know you're not. All right, so here's your magic word, okay, PEZ, okay? Go ahead. What information do you need to know? All right, so I can't read them all. You guys are doing great. I'm glad you're participating. I'm glad we got some interaction. You're awake, okay? So one question would be, what straw length should we use? because straws are of all different lengths. Okay, you see them little ones in bars, little stirrers, and then you've got the huge big ones in milkshakes and so on. So after doing some research, I came up with an average length to be like 7 3/4 inches. It could have been 8, but I thought for a math problem, 7 3/4 was better for our students, so I made it 7 3/4. And again, these are numbers I'm just using just to make the problem interesting. Okay. Another question that I saw came up is either what is the radius of, or the diameter or the circumference of the Earth, okay, at the equator. And I really don't want to give the circumference. I want them to do some math, so I'm going to give them either the radius or the diameter. So I researched this as well, and this is shared on the PDF and is shared in the video. And here's a good old Earth here. It looks like North America, I think, and South America down here. And I found out the Earth is not a perfect sphere, okay? It's not a good basketball. The rotation of the Earth causes it to bulge at the equator, which I did not know that. I knew it was not a sphere, but I did know it was because of the rotation of the Earth. The diameter from pole to pole is almost 7,900 miles, while the diameter at the equator is 7,926 miles. So for our purposes, we're going to, the Earth is called an oblate spheroid, a sphere that experiences flattening at the poles. So for our purposes, we're going to use the equatorial diameter because we want to know what the circumference is at the equator. So we're going to use 7,926 miles for the diameter. Now, the reason why I did it this way and said, what do you need to know in order to solve this problem? I really got this idea from Dan Myers, who many of you know. And Dan and I are friends. I do like Dan. He's given me some great ideas over the years. And I like that idea of this being more of a real world problem. Whereas if someone said, I want you to solve this problem, and I want you to solve this problem, but I'm not going to give you all the information because that's not how it is in the real world. Somebody say, go solve this, and you have to investigate what you need to find out in order to solve it. Now, just a teaching thing here, I can't do this on the video, but in the classroom, when a group would ask me a question and say, I need to know this, I wouldn't tell it. If it was not something they needed to know, I wouldn't say, oh, you don't need to know that. I would tell them if I could. And if they didn't ask me for the right information, I wouldn't tell them. And why not? Eventually, they're going to have to ask me because they need to know that information to solve it. So I'm trying to keep it as real world as possible. All right, so here's the thing. We want to use a calculator for the calculations. Again, don't round intermediate answers, round only final answers. Question, Mike. Oh, I thought I heard Mike say.
Sorry, I was muted. Nope, we're good.
Okay. Let me know if there are, though. All right, so here's our exercise 1. Here are the 3 numbers that you kind of need to know. We've asked the teacher for that information, okay? And now, so we're at solve the problem. And this is where I'd have the students pause the video, do that, and resume when ready. So I'm going to take a chance. I don't know that you can do this in a minute, but give me your best shot. See if you can do this in a minute. I'll give you that much time. We'll see how that works. So go ahead, 1 minute. All right, 10 seconds left. All right, so I'm pretty sure that wasn't enough time, but at least you got started and got to see kind of a plan of action. Let's go ahead and go through this, and this is what I would do on the video as well. And I'm hoping, I know some of you are saying, oh, these kids will go right to the answers. I get that, but I'm hoping some will try it. So let's go ahead and see what's going on here. Okay, so Here's my solution, the way I would look at it. So the first thing I would do is I'd say, all right, I got 500 million of these straws, and they're each 7¼ inches. So I'm going to need to use a calculator here, and do that calculation. And what I want to do is store that into different variables so I can call them back. I don't have to retype them. So let's go ahead and type in. I think what I'll do is I'll use the SmartPad app on my handheld. So I'm going to use my handheld to type in these numbers here. And it fell asleep, so let me wake it back up. Okay, so 500, 1, 2, 3, 1, 2, 3, 500 million times 7.75. I'm getting the same, and those are inches. And then I'm going to store that into Alpha Math, which is the A key, Alpha Math, where that's the red there. Okay, and so A now has that value. And I'm going to go ahead and grab and pull that off so that you can see that. And remember, you can do that with the SmartView emulator. You can slide your screenshot right off into Word or Smart Notebook or PowerPoint or whatever. Okay. All right, so I've got that. Next thing I'm going to do is convert that to feet. So I'm going to have to take whatever I got there and divide by 12. And I know I could use just divide by 12, but I want to use these variables. So I'm going to go ahead and type in alpha A. And then divide by 12 and get an answer. And that's in feet. So I'm going to go ahead and store that into alpha B, the letter B, and drag that off. Click on the screen and pull it off. I can also use my finger because I'm on a touch screen. If I was on a smart board, I could use my finger. I'll use my finger on the next time. So I've got that. Once I've got the feet, I'm going to convert to miles because that's what my other units were in miles. A lot of units conversion here, okay? Not difficult units conversion, but you need to be able to do this. So there's 5,280 feet in a mile. Unfortunately, not enough students know that, okay? I think it's 5,000 since we went metric. It's not, it's 5,280. So I'm going to have to take what's in B, so alpha B, and divide that by 5,280 feet per mile. And I'm going to get 61,000 miles. And let's go ahead and store that into alpha C. By the way, I do know that I can just type that in. Like I can go back and go alpha B divided by 5,280 and store into alpha C all into one line. But I like seeing them both, and that's just me. So again, I'm going to use my finger this time and put my finger on there and slide that off right there. And then I can resize it, move it around, and so on. Okay, one of my favorite features of TI SmartView, by the way. All right, so that's how many miles we've got. The circumference of the equator, we need to find that. So we know the diameter. We were given that diameter of this many miles, and I have to multiply it by pi. And you'll notice I'm not multiplying by 3.14 or 3.14159. I want to use as many significant digits as I can get. Okay, and also everybody will have the same answer if we do that. So I'll go ahead and type in 7926 times pi, and pi is second caret. And so that's how many miles the circumference is, and I'll store that into the next letter, which I think is alpha D, and pull that off. Where I put it, yes, into D. Okay. All right, so now I've got how many miles this here. So it looks like there's fewer miles in the circumference than the length I got for the plastic straws. So I'm going to divide those to see how many times it goes around. So I'm going to take what's in C divided by D, and I'll do that right here. Now, again, on the color calculator, alpha and xt theta n, you do those one after another, and you get the cool little fraction template, which is kind of nice. So I'll type in alpha C, arrow down, alpha D, enter, and it looks like it's about 2.5 times, about 2.5 times from one day. So let me just pause there for a second, catch your breath, see if there are any questions there from online. Mike, you got any questions?
No, I'm just answering one now, whether TI SmartView works on a Chromebook.
It does not, but there is a version, a 84 Chromebook version that if we have time at the end, Mike, I can even show it to them.
Perfect. And also, I'll be giving, with all the documents that we're using tonight and giving away tonight, I have what's called pre-event slides PDF. And in that pre-event slides PDF file, one of those slides in there is how to get the Chromebook app.
Okay, perfect. Yes.
And Jose did mention in the chat window, thanks Jose, that it is currently a beta version.
Yes, it is beta, but it is the beta is just because it's on the Chromebook. The calculator is fully functional. There's no bugs in the calculator whatsoever. So that's a good part too. All right,
thanks,
good
Tom.
questions, good information. All right, so so here I'd ask the students to pause the video, make any corrections, resume when ready, okay, and hopefully we're ready to go. So exercise 2, it says if we connect these straws for the entire year and could place them along the equator, how far would they wrap around the Earth at the equator? And so that's a little bit easier once we've done the first one. So I'm going to go ahead and give you like 20 seconds there. Go ahead and finish that one. If you want to type it into the chat window, go ahead and do it at any time. You don't even have to wait for me. Okay. And then 5, 4. Okay, so how far would it wrap around the Earth if we did this for a year? All right, so the solution would be to take the answer we just got and multiply by 365. Okay, and so that's what we'll do here. Take 365 times alpha E. Oh, I never did store that into alpha E, did I? So let me clear that. And let me go ahead and store that into alpha E in case I need it for something. And now take 365 times E. And I know some of you are probably saying, why don't you just do, answer times 365? Again, get in the habit of having students store intermediate answers. Because I'm sure you realize what you see ain't what you got. There's more significant digits internally being stored than what you see on your calculator. So again, I'll pull that off. And so almost 896.5 times around the Earth in a year, plastic straws would bend around it. Now, it gives me a little bit better understanding that this number is just huge. All right, so exercise 3. If we connect these straws for an entire year and could place them on a straight line from the Earth to the Moon, how far would they make it to the Moon? Would they make it? Would it go too far? Whatever. Okay. So that's the idea. By the way, I hope you guys are enjoying the pictures I have here. I had the Earth before, and I got the Moon. I got all these nasty straws on the beach where they shouldn't be. Again, just enough there to kind of give students the idea this is not a good thing. All right, so again, what information would you need to know in order to be able to solve this problem? Type in your question, but do not press enter or send until you hear the magic word. Got 20 seconds. In 5, 4, 3, 2, All right, Pez. Pez it is. Okay, so you heard the magic word. So possible questions, what is the distance from the Earth to the Moon? I mean, that's a pretty obvious question, but I'm getting the students to even think about that, okay? So even this is going to be a little bit of a lesson. I researched this, went online, and I found out that the orbit around Earth, the Moon's orbit around the Earth, is not a circle. It's an ellipse, and it has something called its perigee, which is the closest approach to it, and the apogee, the farthest it gets away, okay? Um, and an average distance that it gets away, all right? Before we talk about that, though, I thought this was interesting. It says today the moon is moving away from Earth at a rate of about 1.5 inches per year. I just thought that was interesting, okay? And bringing us something else besides just the math. All right, so the perigee closest distance is this many 100,000 miles. The farthest is a lot more. That's a big difference, I think, okay? And then on average, we're going to use this average number, which is about almost halfway between those two, 238,855 miles apart. So those are the numbers we're going to use in our calculation. Okay, so if you need to write that down, go ahead and write that down now. All right, so getting back to this, we did part A. We want to now answer the question, how far would it make it to the moon? Okay. We did part B. We asked the teacher for that part. Okay. So now we want to solve the problem. So I'm going to pause. I would normally pause the video, do what is asked, resume when ready. Again, I'm going to give you about a minute on this. Okay, and see what you can do. So 1 minute, I'll give you about a 10-second warning. Good luck. All right, 10 seconds. All right, so I'm thinking that's probably not enough time to finish it, but again, just enough to give you an idea of what students need to do and how they have to think and using your calculators and so on. So let's go ahead and look at this. So if we connected these straws for the entire year and could place them on a straight line, would they make it to the moon and so on? So this is how many miles is from Earth to moon. So we need to use information found in the first exercise. The length of the straws in miles is given in part C. And we need to divide this number by the average distance to the moon to see and I think this is per day, I think. This is how many miles per day, okay? So we need to divide that. So I'm going to go ahead and take whatever in C and divide it by this distance here. I already did it, but let me just do it with the calculator so people can see that as well. I'm going to go ahead and press clear just to get a clear screen here. Now, again, I can do alpha y equals to get the fraction template, or I can do alpha x t theta n to get the fraction template. So I'll just do the alpha x t theta n. Alpha programs gives me C, arrow down, and then 238, 855, and enter. And I'm going to store that into the letter G. So that I have it. Okay. So in 1 day, it goes about a quarter of the way to the moon. So what I need to do now is multiply that by 365. So 365 times what's in G. And you can see there that it's 93.5 times to the moon. So the length of straws in 1 year can travel a distance from Earth to the moon almost 93.5 times, or that would be about 40, almost 47 round trips. Okay, Earth to moon and moon back to Earth. Okay, Mike, let me pause there for a minute. Any questions or things I should know about?
Just trying to catch up on some of the chat and Q&A. So far, I'd say no, but feel free to check back in a couple minutes.
Okay. You know, I'd like to get people's response here. I'm curious if this pausing and having you do the work, if that's a good idea or not. So you could either say, yes, it's a good idea, or type in, it's annoying. And I'd be okay if it's annoying. I'd be okay with that. I'd just like to know the truth because
so far, Tom, it looks like lots of yeses.
That's good because that's good because I was going to try to react to that, but I'm glad I don't have to. That's good. All right. So exercise 4. Okay. Now, if all these straws are made of plastic, and as I said before, they're not, but I don't know what the percentage is of plastic and so on, what would be the volume of the plastic used to make the straws for 1 year? And now think about that for a little bit. Let me just let you think on that for a few seconds. They're all made of plastic. What would be the volume of the plastic used to make the straws for 1 year? Okay. So again, I want you to think about, and you can type in, but don't press send or anything until you hear the magic word. What information would you need to know in order to be able to solve this problem? Okay, now think about it. I'll give you 30 seconds to think, type, don't press enter. Okay? Timing.
Tom, while people are thinking, I just wanted to share that reading through the chat and the Q&A, it looks like some people are definitely appreciating the time, but they might want some more time.
Okay.
I think.
Okay. Sure. I have it. All right. So 10 seconds, 10-second warning here. So some of you are already jumped the gun. And the word is Pez. And I'm seeing a couple different ways to go here. I think that's several, in fact, more than 2. So I'm going to go one down one path, but I can see that there's definitely another path that you could go. So we did that already. Okay. So possible questions, dimensions of the straw. I saw that pop up a few times. By dimensions, we already know the length. We're going to go with the 7 3/4. But one of the things that I would like to know is the outside diameter of the straw. And I saw some of you went with inside diameter of the straw as well. I also thought it may be the thickness of the straw material. How thick is it that makes up the straw? So with that, here's the information we're going to use. Again, the straw is about 7 3/4 inches long. That's going to be the length. The outside diameter of the straw on an average one that by doing a little bit of research is 3/16 of an inch. Notice I'm getting a fraction again. And then I also have the thickness of the straw is 1/100th of an inch. Very, very thin, okay, very thin. I could have also given the inside diameter to have people subtract or use a, found the area that way somehow, but didn't, okay? So there are a couple other ways you could have done this. So there's your information there. I don't think you need anything else. I think that's enough information. So right now you should be able to solve the problem, okay? Find out what that volume of the plastic would be. And I think we'll go, I'd like to have this maybe in cubic feet. I think cubic feet would be a good answer. Not sure. Now, I told you I'd like to have a little bit more time. And I was only going to go with like a minute, but I think I'm going to give 2 minutes this time. And that's a lot of time for dead air, but I think you're going to take advantage of it. So I'm going to go with 2 minutes. So I'll give you a 30-second warning. So go ahead, do what you can. It's not a race. It's not a race. Just do what you can in 2 minutes.
Thanks, Tom. I just want to add that, again, you're not going to actually press enter until Tom says the magic word. So feel free to type it in, but don't press enter until he says the magic word.
I still have 30 seconds left. 30 seconds, and again, it's not a rush. It's just I don't want to have too much dead air on this. All right, if you have an answer and you'd like to share it, Pez is the word. And if not, if I don't see too many, I'll wait a little bit longer. We had a few people get some answers. All right, so let's see how we did here. Let's see how we did. Okay. So if all the straws were plastic, would be the volume in 1 year. Okay, in 1 year. Okay. So one way the way I was thinking of visualizing this was to take that straw and cut it along a vertical line to flatten it to become a very thin rectangular solid. So if you, I don't know if you can see my cursor here, but I'd like cut it straight down here and then flatten it out. It'd almost be like a sheet of paper. So it's going to look like this. Okay, open it up and flatten it out. Now I know the height of this, or the length of this, is 7.75 inches. I know that. And the circumference of the straw is going to be the width of this straw, of this rectangle rather, okay? And I can figure that out. And I know the height, this little tiny, it's so skinny, is 1/100th of an inch. I know that. So I can find the volume of this very, very short box, so to speak. So what I need to do is calculate the circumference of the outside of the straw. So circumference is pi times the diameter, and so that would be pi times 3/16 of an inch. So I'll bring up my trusty 84 here, whatever calculator I'm using, and multiply pi, not 3.14, but I want to use all the significant digits I can get so that everybody's getting the same answer, times, and then I can do my fraction template, 3/16. And enter. And what that is that's, let us store that into something. Where are we at? Store into H. Did I advance the store into H? No, store into I. So store into, I don't think I stored the last one, but I think I'll be okay. Store into alpha I. There we go. So that's the circumference or the width of my rectangle. So to find the volume, it's going to be length times width times height. And that's what I think is done in the next slide here. This is the volume of 1 day's worth of straws. So this is one straw. So I'm going to have to multiply 7.75 times what I stored in alpha I times the height, which is 0.01 inch. Inch times inch, I say cubic inches. And so that's the volume of one straw. I'll store that into the next letter in case I need it somewhere. And that would be letter J. And then I'm going to look like this. Is that into J? And now I need to find the volume of all the straws. There's 500,000 of them in 1 day. So I'm going to multiply that times J. So again, 500,000. Oops. 500, 1, 2, 3, 1, 2, 3 times J. And then I'm going to store that into alpha K. That's cubic inches. I need to convert that to cubic feet. And this is where students have trouble, right? They think just divide by 12 or some even multiply by 12. Either one is very wrong. Okay, and I want them to be able to visualize a cubic foot that goes 12 inches by 12 inches by 12 inches. So I'm going to need to take my answer in K and divide it by 12 to the third power. That's a cubic foot. So again, I'll get my fraction template, alpha K over 12 raised to the third power, and store that into capital L, alpha L. I'm getting the same answer there. Notice all the significant digits are the same, which is good. And then finally, for a year, I'm going to multiply that by 365. 365 times whatever is in alpha L. And I'm going to store that into alpha M. And that's 4,821,386.837 cubic feet of plastic in a year, just from straws. I'm not talking plastic bottles, I'm not talking plastic bags, I'm talking just from straws, these little straws. Now, before we go on any further, I do want to relate one story. I have become kind of a fanatic about plastic straws. We go out to dinner, and they'll take you all have water, and I'll say no straw, no straw, and they're usually pretty good about that. The server's pretty good about that. I always have a couple who'll come back and they bring me my straw, and they'll say, "Oh, you didn't want a straw," and then they'll take it out of my water and throw it away, and they missed the point. They missed the point. I did not want them to use a straw at all. Okay, we want to use a straw. All right. So anyway, I digress. But still, this number, 4,800,000, that I I can't even understand what that looks like. Does that fill up my backyard? Would it fill up Lake Erie? Would it fill up the Pacific? I mean, I don't know. So I want to get that into some kind of context as well. So that's why I'm not finished yet. So part D says, to try to comprehend what this volume plastic 1 year means, let's look into something we can visualize. All right. So here I have a rectangular box. Okay, this is a rectangular solid, right? What I want to do is I want to cover a football field with this plastic, melted plastic into a type of a box. I want to go from goal line to goal line and the width of the football field. Okay, that's what I want to do. Okay, and what would be the depth of the plastic that would sit on top of that as a box? Excuse me. I hope you all can understand what I'm saying. I want to put a box, goal line to goal line, no end zones, sideline to sideline. Make a rectangular solid with this melted plastic, so I can visualize it. So first of all, what is the width of a football field? And very few people know this. If you know this, type it in and you can hit enter right now. I'm curious how many people know what the width of a football field is. Now here's what's crazy. Some of you put in a fraction of yards. You were right. It's in feet. It's measured in feet, and it's not a whole number of yards. Okay, it's 160 feet wide. I'm not sure who was right on that or whatever, but whatever that is divided by 3 is how many yards it would be. Okay, which boggled me, but I'll get over it. So let's go with our solution here. Okay, again, if you want to, where are we on time? We have time. I think we have time to do this a little bit, but just get started. I'll give you 1 more minute just to get started on this, and then we'll resume. I do want to show you some things at the end. So 1 minute. About 15 seconds. All right, let's see how you did. I'm sure you didn't get finished, and you shouldn't have. Don't feel like you should have been able to do this. It's a time crunch here, okay? So we need to calculate the area of the football field in square feet. Okay, so I'm going to think of the football field as a rectangle that's 300 feet by 160 on the width. And so the area, of course, would just be length times width, which I do need that number. So I'm going to go ahead and multiply 300 times 160, and this would be in square feet. I'll store that into the letter N, alpha N. I need to divide the volume by the area to find the height, because I'm going to be taking cubic feet divided by square feet, and I'll just get linear feet. I could also do the math and show you if that's the case to do it, or some people say, I just get that. So I'm going to have to take what we found in M, all that is cubic feet, and divide it by that area right there. So again, I'll bring up the calculator, and I'm going to press clear since this is our big answer here. So again, getting the fraction, alpha M divided by alpha N, and it's about 100.5 feet high. That's what I'm going to say about Canadian football. I don't know about Canadian football, but 100.5 feet high. So I'd like you to kind of try to picture that. So this is the football field, and this is like 10 stories high, right here, 10 stories high. My goodness, okay? All right, so that's what 4,821,000 something cubic feet of plastic would look like as a box. Okay, where's it going? I don't know, because China's not taking our trash anymore. All right, so with that, let me just pause for a minute. Mike, how we doing?
I think we're good, Tom. Thanks.
Good, okay. All right, so I do supply on the student PDF this information, some background information, because I want to tie in. This is not just a cold math problem, but it has some things to do with the social awareness. Plastic straws are among the worst pollutants in the world. As much as 3 million pounds of plastic straws are used in the United States each day. Plastic straws. I was going to bring in plastic bottles, didn't have enough time to do it, but you can just multiply by what you get with plastic bottles, it'd be a lot. Environmental effects of plastic straws. The death of many marine animals is attributed to complications by ingesting plastic straws because they're non-biodegradable. Plastic straw basically lives forever. You put it in a dump, it'll be there hundreds of years from now. Could a ban be the answer? Some states are thinking of doing that. California went to bans on plastic bags in grocery stores. Some countries are using plastic to reusing them to make mats and bags, which is at least reuse them somehow. An alternative to plastic straws, one of my favorite ones is straw. Where do you think we got the word straw from? Think of straw, like, hey, use a straw. Of course, it's not practical, but it could be. So those are some of those things there. All right, we have a couple of websites we could go to, but I'm going to go away from that. I only show you some other things first. So for example, the website I created for this activity, this is one you could just give to your students and say, this is what I want you to do. I want you to watch the video, do it along with the teacher there, and take a picture of your work and send it to me so I know you've done it, and hopefully they have. So that's up to you. So these are links here. So if you click on plastic straw activity video, it will take you to my YouTube channel, and there it is. Okay, so there's that right there. What else have we got? The student PDF, if you click on that, here's the student PDF, and you can download it directly from my Dropbox. And it's basically exactly what we did here, including the information at the end with the links. Okay. It also has a link to the teacher notes and solutions, and it has all those things that I just had in the video and on the Smart Notebook. So it shows you how to get them. What else is there? My contact information. And I'd also like to put in a plug, since I have a minute or two here. I have several webinars coming up. I have one this Thursday on geometry for remote learning. So if you're interested in that, you can click on there, and it'll take you to the guy's YouTube channel. And you can go ahead and see it streaming for about 45 minutes to an hour there. Okay, that's coming up. And I also have quadratics the following Thursday on the iPad, so you can do it on the activities I'll show will work on any platform, not just iPad. Modeling disease data, that'll be on the Chromebook app that somebody asked about, and also on the 84 color calculator. Okay. You can always get the free software from here at TI's website. Mike, do we have time to show the Chromebook real quickly or not?
Yeah, let's do it.
We do it? Okay, so I'm going to go ahead and find my home screen here, and I got on my on my computer, I have to run Reflector. You don't have to do this with the Chromebook app. I'm just using this so that you can see it here. So I'm going to need to go to my Chromebook and type in this code. Again, this has nothing to do with what you have to do. This is just so that I can share my screen. And do that. 4, 0, TV 14. Says I'm sharing my screen. Oh, you know what? I was already doing it. That's the problem. I'd already had it done. And so let me try that again. Sorry about that. Again, what I'm doing, you do not need to do. Okay, you do not need to do this. Of course, I would have technical difficulties here. There it is. Okay. All right, one more time. This doesn't do it. We'll have to go to something else. 0. No, unfortunately, it's not doing it for me.
Well, Tom, I can vouch for you. Before we start tonight, Tom and I just tried it out, and it did work really well.
Yeah, and so sorry about that. I apologize, but it does work. And where you can get the app is Mike will have that on the on there. But if you go to TI's website right here and go to COVID-19 support and download free software, these are all the solutions: the iPad solution, the Chromebook solution, right here, right here. It's that easy to get. Complete a form, submit it within a day or two. At ETC from TI will send you a code that allows you to use it for like 6 months. I think we'll till August 15th. Students can use it, teachers can use it. If your students need to have it through your school, your IT coordinator can blast it out to every student in the school. So again, I saw somebody saying, where do you get the PDFs? This activity right here, and the probably the link. Let me show you the link real quick. Sorry about that. So the link is a bit.ly link, and it's right here, bit.ly/plasstraw. I thought that was pretty clever of me. Plastic straw, kind of put it together, all lowercase. Any other questions, Mike, before you close this out?
No, I think we're good. I think a lot of people are just looking for the certificate, which I'll be sending out here in a minute.
Okay. All right. Well, thanks everybody for coming. I hope you're all safe. I hope your family's safe. And let's get through this.
Thanks, Tom. Can you give control back to me?
Oh, sure. Sorry.
It's tough. Whenever you give Tom control, he doesn't usually want to give it back.
No, I am pretty much a control freak. You're right about that. No doubt.
So Tom mentioned at the beginning of the webinar that one lucky winner will be receiving a T-Cube Summer Workshop registration tonight. And tonight's lucky winner is Linda Carpenter. So Linda, congratulations. We hope to see you as well as everyone else at a T-Cube Summer Workshop. Linda will be sending you an email in a couple of days to give you a little more information. But please feel free to visit our website, everyone, to learn a little more about some upcoming T-Cubed Summer Workshops. To receive a certificate of attendance for tonight, go ahead and click the link that just appeared in the chat window. Also listed is a link for the documents that Tom shared, as well as my documents as well. And if you're missing those for any reason or they're not working for you, just hang tight and you'll get an email in a couple days And that follow-up email will be links to the recording, the certificate, and the documents as well. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Tom, thanks so much for everything you shared tonight. It's exciting to not just be doing just math, but math that can really impact the world. So I really appreciate everything you shared.
Sure, it was fun. I'm glad we had a nice turnout, too.
And thanks, everyone, for joining us. We hope to see you back online real soon. Have a great night and stay safe.